Assalamu alaikum. Myself Arsalan Izwan. I'm a student from Mechatronic Engineering, currently studying in the 4th semester from Air University. The topic that we are going to discuss is related to computers now. First of all comes the introduction to computers. The topics we are going to discuss are internal organization of computers. There are basically three main different parts of a computer that includes the input and output, the memory and CPU. Input output means that devices that are used to communicate between the machinery and the human. So this may include speakers as the outputs, keyboard as the inputs, and so on, very more. Now coming to memory, so there are different types of memories, some are semiconductors, some are non-semiconductors. We have as examples floppy disks, RAM, ROMs, hard drives, hard disks, sorry, and many more. We are going to discuss all these topics one by one. CPU is abbreviated as Central Processing Unit. Now coming to next, connecting the different parts, connecting memory to CPU, connecting input output to CPU, how computers work. These are the three main basic topics we are going to discuss. First comes the internal organization of a computer. The internal parts that a computer has. These are central processing unit, memory, input output. Examples of input and output are given likewise. Now we have memory. So to define memory, we can say that it is a device that can store memory. It can retain it and recall it whenever we need it. For example, hard disk and a piece of paper. A piece of paper is also some sort of memory, like if you have written something in your register or in a notebook, you can at any time you have the access to the notebook, you can check what was written and what was the information in it. Now memory characteristics include the capacity, organization and access time. And in capacity, we have the total number of bits that a memory can store. For example, 128 kilobits and 256 megabits. The organization of these locations, the organization of this memory is like 128 cross 4. Memory has 128 locations and 4 bits each. It means that there are 128 locations in that memory, and each of those location can store a data that is total of 4 bits. A 4-bit data can be stored in each of that location. Then comes the access time. How long does a memory take to store the data? So different types of memory are semiconductors and non-semiconductors. The non-semiconductor memories are out of date. They are no longer very compatible with the softwares and the hardwares that we have currently. The semiconductors are the ones we use, and I am sure that you are very well aware of the semiconductor memories like ROM and RAM. The non-semiconductors may include floppy disk, etc. Now comes ROM. It is abbreviated as read-only memory, and RAM, it is abbreviated as random access memory. So there are different types of ROMs. First is mask ROM, PROM, EPROM, double EPROM, flash EPROM. And in RAM we have static RAM, dynamic RAM, non-volatile RAM. You can also write them as SRAM, DRAM and NVRAM. Coming to next slide. So first of all we are going to discuss about mask ROM. So mask ROM is a ROM that is basically programmized from the manufacturer. The manufacturer who builds this memory installs the program within it, and we cannot access it, like we cannot change it or enter any of our own programs. So PROM, it means programmable ROM. We can program it, but it can only be programmed once. We cannot change it again and again. So the program that's been once installed in it cannot be changed. And then comes EPROM. It is abbreviated as erasable programmable ROM, and you can erase the data by using ultraviolet radiations. Either you can place it in a unit or a device where it emits ultraviolet radiations to remove its data, or you can place it in sunlight, and sunlight also has ultraviolet radiation, so it will erase its data as well. However, it takes 20 minutes to erase or to erase all of its data, and we have to take it off the circuit and the device that it's currently in use, and then place it in the environment where we have ultraviolet radiations to remove the data. That's the disadvantage of it. Down there we have a table 0/5, and it gives some different models of EPROM. along with their capacity or organization, access time, pins, and the power supplies. Then comes double EPROM. It is abbreviated as electrically erasable programmable ROM. The advantage of this is that we do not have to remove the ROM from the device. We can easily remove the data within it using the program that we have. And so in this we have to erase the data separately. Every byte needs to be erased separately. We cannot erase it in an instant, and the table below gives all the specifications, part number, capacity, organization, speed, pins, and VPP. Then comes flash ROM. So in flash ROM, as the name states, it can erase the data in a flash, like in a second or in an instant, you can say, but we cannot erase the data like separately or one by one. We have to flash it all out. We have to erase it all at once. The data of the flash ROM is stated in this table below. Then comes semiconductor memories. Basically, now we have covered ROMs, and now we are going to discuss RAMs. In RAM, we have first of all static RAM, SRAM. It is basically made of flip-flops, and the advantages are that it is faster, it does not need any refreshing. The disadvantages in it are that it uses high power and it is expensive, as because it is made of flip-flops and its size is quite big. Then comes DRAM, so dynamic RAM. It is made up of capacitors. Advantages are it uses less power, it is cheaper, it is high capacity. Disadvantages are that it is slower, refreshing is needed. Then we have NVRAM. It is non-volatile RAM. It is basically made of SRAM, battery control circuitry. And SRAM, as you have seen already, that it is faster and it does not need any refreshing. So we already know that it's going to be fast, and it has a battery and control circuitry. Advantages are it is very fast. It is infinite program cycle. We can program it as many times as we want. It is non-volatile, and disadvantage it is expensive. So according to these slides that we have studied, the best one among these three is NVRAM. Only the disadvantage is that it is expensive. Then comes internal parts of the computer, that is CPU. So first of all, it should execute instructions. That is the basic function of a CPU, that it has to execute the functions that we give it through our human language, and it converts it into some machine language, that is binary language. We are going to discuss that in a while. So it should recall the instructions one after another and execute them. Then comes central processing, connecting memory, connecting memory to CPU. We have to connect this memory to the CPU, as it does not contain its own memory unit. We have to connect a memory unit with it. So these are some memories pins. This D0, D7 is data pin, and this is address pin. OE means output enable, CS means chip selection, this is ground, and this is VCC. So this WE over here means write enable, this OE means output enable, CS is chip selection. So the bar indicates that these are to be turned on when the input is 0, and when the input is 1, these are off. Then comes the basically connection with CPU. Data line, CPU does not have its own data, so it has to take the data from this memory unit, and then comes it's simply the connection. Now, as I told you, whenever the write enable input is 0, it will store the data. Basically, from this unit to this, from this point to this point, the WE is on, that is the input is 0 and the write enable is on, and so is the chip selection. Then whenever the WE is 1, that means it's off, and output enable is on, as well as the chip selection is on. Now we have input output devices connected to CPU, and CPU should have lots of pins. Now these are input output devices as examples. This is data bus, address bus, and control bus. This is basically CPU. No, yes, the memory unit is also connected now. Is the cursor? Yes, the memory unit is also connected now, along with these input output devices. Then we have it connected to the input output devices as well. Basically, first it was not connected to the devices, input output devices. Now it is connected to them as well. Now we have the method to arrange these, to use these input out devices and CPU to get our task required. So first of all, we have the logic circuit. Logic circuit is basically connected to chip selection. It is one of the most important things that we have to discuss now. How do we manage this? How do we make this logic circuit? First of all, we write the address range in binary, whatever the range is. Like over here they showed is from 0 to 15, so we are going to write the addresses in binary as 0 to 15. Then we are going to separate the fixed part of the addresses. That means the part of the addresses which are same. So from here you can see that 0 to up to A40 is same from in both of the 0 address and 15 address. Now we are going to fix these. Then using NAND gates we are going to design a logic circuit that is going to give us the output required. This is the output going to chip selection, and this is the input that we have basically taken from this binary numbers. As an example, we have 300H to 3FFH address. It is in hexadecimal. We are going to show you this example. Likewise, we have written 300H in binary. Again lost the cursor. Yeah, the 300H is written in binary, as well as the 3FFH is written in binary. Then we see the area, the part which is fixed, that means it does not change. Up to A8, from A11 up to A8, we can see that these are fixed, these are not changing. So we're going to log these. Then we are going to make a circuit design using NAND gates like this. Okay, now coming to next. So inside the CPU we have a program counter, instruction decoder, and arithmetic logic unit and registers. This is the now we are going to discuss how do the computers basically work. So we have the memory box connected as well as the input output devices to the CPU. This is program counter. This is instruction decoder, arithmetic logic unit. Basically this is the unit where arithmetic operations are performed. This is the registers. This is the human language program, and over here we have program counter, and I guess it was program counter. Yes, program counter. This is program counter, and over here we have information, the data that is written in hexadecimal. So now moving on. First of all, what happens is the program counter gives out 0 as it needs to access the data line wise separately. In 0 we have 31H as the information. So what's going to happen is this 31 is going to go to instruction decoder. After that, the data that is stored in this is going to come to the A. How so? We know that in the 17 input output device, the data stored in the 17 input output device is going to the register A, and the data stored in this is 9. As you can see, it is now on address A, register A. Then the second line we have that A, the data stored in A is now going to be copied to B, and the program counter is now changed to 1. So we can see that 1 is going to the address bus. This address bus, now we have the data C4, which is going to come over to the instruction decoder, and then it's going to copy the 9 to B, because 9 was the data that was stored in A. The program counter is now shifted to 2, and now we are going to have 26 as our instruction decoder. As you can see, now 26 is our instruction decoder. The third line states that the data stored in the 6th program counter is going to be stored in A now. So we are going to overwrite the data stored in 6. You see there, the data over here is 5. The 5 is going to replace 9 of register A. As now it is replaced, now we are going to go to the next step, that is A plus B, which is going to be stored in A. Coming up to the next a program counter, that is 3. Its data, its information, its instruction is 81. 81 is going to come to the instruction decoder and it's going to perform the arithmetic operations. How so? First of all, it's going to take the data from both of these A and B registers, 5 and 9, and it's going to give us the output as E, because it has to be in hexadecimals. And that E is stored in A because that was the program set by the human language. And coming to the next program counter, that is 4. Now it's going to give out 4 to the address bus, and we have EA as our instruction decoder. This instruction decoder is going to come here, and we're going to perform to the next program counter, that is 5. The next human language code is that the data stored in A is now going to go to the program counter number 7. How is that going to happen? It's going to happen like this. The data in A goes to the data bus, and that data bus is now going to write it over this 7. So then we have how instruction decoder works, the working of this specific part. Instruction decoder basically has opcode and operand. So this is human language, this is machine language, and these are the instruction tables that we have. Opcode is the operation code. It runs step by step, and the operand is this meaning. This meaning is converted into the binary language and then comes to the operand. Now we have two basic hardware types. One is von Neumann and the other is Harvard architecture. In Harvard architecture, we have different data buses and address buses and control buses for both the data memory and code memory. However, in von Neumann architecture, we have the same buses going to code memory and data memory. So then I guess that's all in this slide. Coming to the book. So in book we have now okay. So in book now we are going to discuss 0.2. It has information related to gates. First we are going to discuss logic gates. First of all, we have all the truth tables on this side and the explanation over here along with this the sign of the gate. So in AND gate, whenever any input is 0, the output is going to be 0. Then comes the OR gate. Whenever any input is 1, output is going to be 1. Then we have a tri-state buffer. In tri-state buffer, you can see we have a control unit and an input. The input is going to the output, but the only difference is that we can control it. Then we have inverter. Basically, it is a non gate. Whenever input is 1, output is going to be 0. And whenever input is 0, output is going to be 1. XOR gate is whenever both the inputs are different, the output is going to be 1. Whenever they are same, the output is going to be 0. Likewise, we have NAND and NOT gates, and then comes basically half address, full address. This is basically DLD, and some important terminology. So these terms are important. Bit is represented as 1 bit. A nibble consists of 4 bits, a byte consists of 8 bits, and the word consists of 16 bits or 2 bytes. Then we have internal components. It's the same as we discussed already. The input, output, and the memory, the CPU, all of this stuff. Now we are going to discuss about the conversions. That is the topic 0.1. We are going to discuss conversions from different bases and how to add and subtract them. I'm going to show you on my register now. सबसे पहले कन्वर्जेंस देख लेते हैं. अगर आपने किसी भी फॉर्म में से बेशक बाइनरी हो, ऑक्टल हो या हेक्साडेसिमल हो, अगर उससे डेसिमल में कन्वर्ट करना है, ठीक है, ऑक्टल से भी डेसिमल, हेक्साडेसिमल से भी डेसिमल, तो आप इसमें लगाते हो पावर सीरीज एक्सपेंशन. इसका तरीका मैं बाद में बताता हूँ. और अगर आपने कहते हैं किसी में भी जाना है, यहाँ से अगर बाइनरी से ऑक्टल जाना है या डेसिमल से बाइनरी जाना है या फिर डेसिमल से ऑक्टल जाना है या फिर डेसिमल से हेक्साडेसिमल जाना है, तो आप लगाते हो फॉलो रूल. अगर ऑक्टल से हेक्साडेसिमल जाना हो ना, तो उसके लिए आपको ऑक्टल से पहले डेसिमल में कन्वर्ट करना पड़ता है. अगर बेस 8 से बेस 16 में जाना हो तो उसके लिए आपको पहले करना पड़ेगा बेस 8 को या तो बेस 2 में या बेस 10 में कन्वर्ट करना होगा। बेस 10 में कन्वर्ट करना आसान है, क्योंकि किसी से भी हम बेस 10 में जाएं तो पावर सीरीज एक्सपेंशन लग जाती है। तो बेस 10 में करेंगे हम पहले पावर सीरीज एक्सपेंशन लगा के, फिर उसको हम कन्वर्ट करेंगे हेक्साडेसिमल में फॉलो रूल लगा के। ठीक है, डेसिमल से मतलब सिर्फ डेसिमल में जाने के लिए पावर सीरीज एक्सपेंशन है, बाकी सब में जाने के लिए फॉलो रूल है। तो अब ये होते क्या है, पावर सीरीज एक्सपेंशन बेसिकली होती है, सपोज के हमारे पास नंबर है 110,100.10 की पावर बेस 2, ये है बाइनरी में। इससे हम अब जाएंगे डेसिमल में। ठीक है, या ऑक्टल से भी है तो इससे डेसिमल में जाना वो मैं बताता हूँ। अच्छा, अब हम पावर सीरीज एक्सपेंशन कर रहे थे, पावर सीरीज एक्सपेंशन। ठीक है, तो अब चलो ठीक है, इसमें क्या करना होता है, ये जो पॉइंट होता है इसको बेसिकली कहते हैं रेडिक्स या बेस कह लो। जो इस साइड पे पॉइंट्स हैं ये इंटीजर पार्ट्स हैं, और इस साइड पे ये मेंटीसा पार्ट है, यानी फ्रैक्शनल पार्ट है। ये फ्रैक्शनल पार्ट है, और ये करैक्टरिस्टिक भी कह लेते हैं इसको, करैक्टरिस्टिक या फिर इंटीजर्स। ठीक है, इंटीजर्स और मेंटीसा। तो जब हमने इंटीजर्स पे पावर सीरीज एक्सपेंशन लगानी है, अच्छा किसी से भी बेस 10 में जा रहे हैं ना, तो जिससे जा रहे हैं वो यूज़ करते हैं। अब इधर मैं पहले यहाँ से शुरू राइट से करना होता है। 0 मल्टीप्लाई बाय 2 की पावर 0 प्लस 0 मल्टीप्लाई बाय 2 की पावर 1 प्लस अब यहाँ पे क्या है 1 मल्टीप्लाई बाय 2 की पावर यहाँ आ गई 2 प्लस अब यहाँ पे 0 है, 0 मल्टीप्लाई बाय 2 की पावर 3 प्लस 1 मल्टीप्लाई बाय 2 की पावर 4 प्लस 1 मल्टीप्लाई बाय 2 की पावर 5। पॉइंट से इधर के लिए, पॉइंट से उधर जाना है तो उसके लिए करेंगे प्लस, अब यहाँ पे 1 था, 1 मल्टीप्लाई बाय 2 की पावर -1 प्लस 0 मल्टीप्लाई बाय 2 की पावर -2। पॉइंट हमारे पास बेसिकली वो 0 से उस साइड और इस साइड डिफ्रेंशिएट करने के लिए, इसलिए अगर पॉइंट आ जाए तो पहले ये किया फिर ये कर लिया, इस 0 से -1 वाली साइड गए और ये 1 वाली साइड गए। ये पावर सीरीज एक्सपेंशन है। ये बाइनरी से बेस 10 में था ना, इसी तरह आप ऑक्टल से भी बेस 10 में जा सकते हो और हेक्साडेसिमल से भी बेस 10 में जा सकते हो। इसमें क्या फ़र्क पड़ेगा, इधर 2 की जगह 8 आ जाएगा और इधर 16 आ जाएगा। अगर ये हेक्सा से बेस 10 में जाना है तो 16, अगर ऑक्टल से बेस 10 में जाना है तो 8। ये हो गया पावर सीरीज एक्सपेंशन। अब दूसरा है फॉलो रूल, इसको कह लो डिवीजन। सिंपल सी बात है, अब डिवीजन तो डिवीजन ही है डिवीजन कर रहे हैं, अगर यही नंबर है हमारे पास डेसिमल का, तो सारे को सॉल्व करने का कोई नंबर आएगा। मैं कहता हूँ 86 बेस 10 में बनता है। ठीक है, इससे अगर मैं बाइनरी में जा रहा हूँ तो 2 से डिवाइड कर देंगे, अगर इससे मैं ऑक्टल में जा रहा हूँ तो 8 से डिवाइड कर देंगे, इससे मैं हेक्साडेसिमल में जा रहा हूँ तो 16 से डिवाइड कर देंगे। बस यही फ़र्क पड़ेगा। फिर करना क्या होता है, जो आपका रिमाइंडर आ रहा होता है उसको सेव कर लेना होता है। अगर इधर मैं 10 से कर रहा हूँ तो 10 8 80 आ गया। ठीक है, और यहाँ पे आ जाएगा रिमाइंडर क्या है, रिमाइंडर 6 रिमाइंडर है। ठीक है, फिर आगे तो हो ही ना, तो ये हमारे पास से आ जाएगा ये ऐसे। इसमें क्या होता है, फ्रॉम लो टू अप साइड, यहाँ पे मोस्ट सिग्निफिकेंट डिजिट होता है, यहाँ लीस्ट सिग्निफिकेंट डिजिट होता है, डिजिट। ठीक है, तो अब ये हमने कन्वर्ट किया है बेस 10 से बेस 10 में कर दिया। बहुत अच्छे ओल, ये मैंने बेस 10 से बेस 10 में कर दिया, तो इसलिए ऑटोमेटिकली वापस 86 आ गया, क्योंकि ये भी बेस 10 ही था। बेस 8 से करते हैं बेसिकली। ठीक है, तो 8 10 80 आ गया। ठीक है, 6 बच गया हमारे पास, 6 इधर, तो आ गया 106। तो बेस 8 में ये नहीं हुई, ये हो सकता है आगे 10 आ गया, फिर 8 1 8 और 2 बच गया। फ्रॉम लो टू अप, फ्रॉम मोस्ट सिग्निफिकेंट डिजिट टू लीस्ट सिग्निफिकेंट डिजिट। बेस 8 में आएगा 1 2 6 बेस 8। ये है अगर आपने किसी भी नंबर में जाना है, मतलब डेसिमल के अलावा, डेसिमल में जाने के अलावा किसी भी नंबर में जाना है तो भी कर सकते हो, डिवीजन से कर सकते हो। ओके हो गया। अब पॉइंट्स में अगर आ जाए, यानी अब 86.03 था हमारे पास। ठीक है, तो इसमें क्या करना पड़ता है, मुझे जो 0.03 वाला हिस्सा है इसको हम उसकी बेस से मल्टीप्लाई करेंगे। इधर हम 8 से मल्टीप्लाई करेंगे क्योंकि हम 8 में जा रहे हैं। 8 से मल्टीप्लाई करेंगे, कुछ आंसर आएगा। तो अगर पॉइंट्स यहाँ जो हिस्सा है उसको सेव कर लेंगे, ठीक है। फिर जो बाकी हिस्सा बचेगा उसको यहाँ लिख लेंगे, पॉइंट समझ लो 35 बचा है, ठीक है। फिर उसको दोबारा 8 से मल्टीप्लाई करेंगे। तब तक करेंगे जब तक हमारे पास एक होल नंबर नहीं आ जाता या फिर दोबारा कोई नंबर इनमें से रिपीट नहीं हो जाता। फिर क्या करना है, जो हमने नंबर सेव किए हैं पॉइंट से पहले वाले, इनको हमने लिखना है फ्रॉम अपवर्ड टू डाउनवर्ड। फ्रॉम अपवर्ड टू डाउनवर्ड, इधर मोस्ट सिग्निफिकेंट अपवर्ड वाला होगा और लीस्ट डाउनवर्ड वाला होगा। तो यहाँ पे समझ लो 1 2 3 आया है और यहाँ 4 है, तो हम लिखेंगे 80 और बल्कि 126 में आया, 126.1234 आया, 1234 की बेस 8। ये इस तरह करना है सिंपली। अब मैंने समझ लेके यहाँ पे ना 4 पे जाके मेरा पूरा होल नंबर बन गया था 4 ना, तो मुझे आगे करने की ज़रूरत नहीं थी क्योंकि 0 0 से मल्टीप्लाई करता आगे 0 ही आना था, तो उसकी कोई ज़रूरत नहीं थी। अगर यहाँ पे 1 2 3 था और यहाँ पे तो 2 आ गया, 3 आ गया, फिर अगर दोबारा कुछ चल रहा है, ठीक है, 2 चल रहा है दोबारा, फिर दोबारा मेरे पास 4.123 आ गया, तो फिर हम इसको यहाँ पे रोक देंगे और इस सारे को लिखेंगे 1 2 3 4 1 2 4, यहाँ पे ना 1 2 3 4 1 2 4। जब रिपीट हो गया, ठीक है, या फिर एक पूरा होल नंबर बन गया, तो इसको रोक देंगे। फ्रैक्शनल पार्ट के लिए डेसिमल इंटीजर पार्ट सिंपल है, इंटीजर पार्ट में सिंपल डिवाइड करना है, फ्रैक्शनल पार्ट में मल्टीप्लाई करना है। इंटीजर पार्ट में फ्रॉम लो टू अप जाना है और फ्रैक्शनल पार्ट में फ्रॉम अप टू लो जाना है। अब अगर हमें ऑक्टल में नंबर गिवन है, जैसे ये है 126.1234, इसको हम डायरेक्ट हेक्साडेसिमल में नहीं कर सकते, इसको हमें पहले करना पड़ेगा डेसिमल में। वो करेंगे हम पावर सीरीज एक्सपेंशन में, ठीक है। पावर सीरीज एक्सपेंशन से हम करेंगे इसको डेसिमल में। वो कैसे करेंगे, बेस 8 है तो 8 की पावर 0 मल्टीप्लाई बाय 1 प्लस, नहीं 1 नहीं है इधर 6 है, 6 प्लस 8 की पावर 1 मल्टीप्लाई बाय 2 प्लस 8 की पावर 2 मल्टीप्लाई बाय 1 और प्लस 1 मल्टीप्लाई बाय 8 की पावर -1 और ऐसे चलते जाएंगे। जो आंसर आएगा वो डेसिमल में होगा। फिर जो डेसिमल का आंसर आएगा उसको 16 से डिवाइड कर देंगे हम, फिर वो जो आंसर होगा वो आपका बेस 16 में आएगा। So that was all about computers and conversions. I'll see you in the next video. Thank you.